Welcome everyone. The question is the two resistors A and B. Obviously their name is given A and B and resistances are 2 ohm. The values of the RA and RB we can say 2 ohm. So let us write that is my RA and that is 2 ohm and that is my RB and that is 3 ohm. Are first joined in parallel and then in series. In each case the supply voltage is 5 volts. So we have to find it on mainly what we have to find it. We have to find it what are the current through it, what are the potential drop across it. Okay. So let us at first join these two resistances are in series. So this is my RA, this is RA and another resistor is RB is here. So RB is here. So we know previously if two resistances are connected in series, then obviously the same current flows through it, and here I am connecting this 5 volt EMF cell. This is the 5 volt EMF cell, and if this 5 volt EMF cell is connected across it, then what will happen? Then obviously a current will start flowing, and that flows through RA and that flows through RB. Okay, so to find it out what is the main current, we have to calculate what is the equivalent resistance of the circuit. So we can say since these two resistances are connected in series, I am saying RS, and this RS is simply RA plus RB. What is RA? RA is 2 ohm. What is RB? RB is 3 ohm. What is the total? Then 5 ohm. Then what is the current through this? To find it out, we have to draw what is the equivalent circuit. Now this RA and RB should be replaced by single one resistor, and that is RS, and that is connected across this 5 volt, across this 5 volt. So this is the 5 volt and the resistance is 5 ohm, and the current through this RS is I equal to 5 volt divided by 5 ohm, so that is 1 ampere. Okay, so the current through the resistors RA is 1 ampere, through the resistor RB which is 3 ohm it is again 1 ampere. We can say this is my IA current and this is my IB current. Okay, so resistance, so current through the RA is 1 ampere, current through B is 1 ampere. What is the potential drop across them? So potential drop across resistance RA, we can say that is VA. VA is equal to IA multiplied by RA. What is IA? IA is 1 ampere. What is RA? RA is 2 ohm. So what is the potential drop across RA? That is 5 volt. What is the potential drop across RB? That is IB multiplied by RB. What is IB? IB is same 1 ampere because the resistances are connected in series 1 ampere. What is the resistance? Value of resistance RB? That is 3 volt. Okay, so sorry, here 1 into 2 is 2 ohm, 2 volt. Here is the mistake. If you have done the mistake, it can be easily identified because the potential drop across RA which is 2 volt and the potential drop across RB which is 3 volt, the sum of these two should be equal to the supply, that is 5 volt. So if any kind of mistake is there, you can easily identify this thing. Now if these two resistances are connected in parallel, okay, so let us connect in parallel. Let us do it in another page. So here is, we can say my RA, this is RA and this RA is 2 ohm, and another resistance is RB, that is 3 ohm, and these two resistances are connected in parallel. So here I am joining like this way, then we can say these are connected in parallel, and now this is connected to this 5 volt source. Okay, this 5 volt source. Now just see, since they are connected in parallel, so the potential drop across both of them, that means if I want to say what is the potential drop across RA, that is VA, what is the potential drop across RB, that is VB. Okay, I am just saying it is VA prime, VB prime, because series in case of series we have denoted the potential drop as VA and VB. So VA prime, VB prime. So VA prime and VB prime both are equal, since no other resistances are connected here, so we can say that is equal to the supply, that is the EMF of the battery, that is 5 volt here. And now since same potential drop is here, that is 5 volt is connected here. Okay, so the current through RA, I can say this is my IA prime, and current through RB, we can say this is my IB prime. So what is IA prime? IA prime is simply VA prime divided by RA. What is VA prime? VA prime is 5 volt. What is RA? RA is 2 ohm. So what is the current? The current is, we can say 5 by 2, that is 2.5 ampere. Okay, what is IB? What is IB? IB prime is 5 volt. What is the current? Sorry, what is the resistance? Resistance is 3 ohm. Okay, so 5 by 3, 5 divided by 3 ampere. This is 5 by 2 ampere, 2.5, and this is 5 by 3 ampere. You can leave it like this, so you need not to put all the times in decimal fraction. You can also put it, this is my 5 by 2 ampere. And obviously, if you just add this IA prime and IB prime, okay, if you add this IA prime and IB prime, you will get what is the total current. What is the total current in the circuit? We can say I prime. And here this I prime, what is the total current in the circuit? Obviously, it is divided into two equal parts. Not equal parts, but divided into 2 parts. Okay. So what is IA prime? IA prime is 5 by 2. What is IB prime? IB prime is 5 by 3. So we can take simply this 5 common. So we can say 1 by 2 plus of 1 by 3. So this is 5 and 6 is LCM. So it is 3 plus 2. So that becomes 25 divided by 6 ampere. 25 by 6 ampere is the total current. And this current is divided into two parts, not equal, 2 parts. One is 5 by 2 ampere here, and there is 5 by 3 ampere here, and again there it is joined and again form the I prime. So what we have observed here, that is in case of series, when resistors are connected in series, in that particular cases the same current flows through it, but the potentials are different, and the sum of the potentials here, since no other resistances are here, so sum of the potential should be equal to the EMF cell. And here in case of the parallel, we have seen that since they are connected in parallel, since no other resistances are here, so we can say the potential drop of the across this RA and RB should be equal to the EMF of the cell, that is 5 volt. And after we have calculated the current, the currents are different, potential drops are same. We can also do it in a different way. We can also calculate what is the equivalent of RA and RB, and that is, we can say RA multiplied by RB divided by RA plus RB. We can do in this way also. What is RA? RA is 2. What is RB? RB is 3. RB is 3 divided by 2 plus 3. So we can say this is 6 by 5 ohm. That is the equivalent resistance of this RA and RB in this circuit. So I can simply say this is the simple resistance which is the equivalent of RA and RB connected in parallel, and this is connected to the 5-volt source. Okay, into 5-volt source. And what is the main current through the circuit? That is I prime. Actually I am checking here. So what is I prime? So I prime is equal to 5 volt divided by RAB. What is 5? It is 5, that is the source. What is RAB? RAB is my 6 by 5 ohm. So see, again 25 by 6 ampere comes as answer. So you can do it in this way, you can do it in that way also. Both the procedures accept. If you follow any of this procedure, obviously you will get marks. Okay. Thank you all of you.